Okay, another manual. This is, you know, that the Ch3 has that new manual of seismic observatory practice, and 2 years ago we discussed and we decided to add a chapter as a complement on analog seismogram processing. Let's see. The next one, the main topic is that because the digital era makes a big change and much more performance of the instruments, the old ones were just thrown away. And the young people lose the know-how about how to use the seismograms. 2 weeks ago, we have a young seismologist training course in Lisbon of Ch3, and there was around 40 students, around 30 years old. Not so young, but well. I asked, how many of you had ever an analog paper seismogram in hand? 6 of 40. Somebody says, yeah, the old people, we know. But the young men, this is the progress, let's say. But these analog seismograms, they cover 2/3 of the recording time we have, of the instrumental recording time we still have right now. Thus it is important to use them even for nuclear explosions. We know from 45 up to the almost 70s. Entering the 80s, if you want to look at the seismic records, you have to look to analog records. That's all. And the idea is to put together a lot of information. The information exists. It was published in due time, let's say, but is lost. And young people, it's lost in all publications. And if you don't know, you might lose a lot of time trying to get this information. And the idea is put all this information together for any person new that go to that topic to move, to easily go to work. We started, let's say, in the 40s. I'm not going to the origins of seismology, but in the 40s, these were still the main instruments, the Galitzin, the photographic, and the Viger. Later, we have the Benioff, the WWSN, the Kirnos instruments also in the Soviet side, that's what they were performing also very good. All this was recorded in analog, like those. There is a lot of variety. There is the smoke paper from Munich, the WWSN from Jerusalem, the other is short period, a Geotech from Italy. The 3 last ones are from the earthquake of Friuli, 1976. And the last one is Irkutsk, recorded in a Kirnos instrument with the 3 components. For a student that has 7 seen this, this looks strange for the older people here, as doesn't look, but young people. And what are these lines, these peaks in the, etc. Well, these are the bases, and we find them in archive in all observatories. I'm not commenting this. The main idea is we have an analog seismogram here, a nuclear explosion from China in 1992. And, we have to digitize. The idea is those are waveforms. And if you have them digitized, we can use everything we know now. They have some limitations on dynamic range, on amplification, etc., but we can use the same tools. And this, we can digitize. This is the first step. Normally, we pass through scanning right now. Digitizing. This seismogram is not yet ready to work with it, needs some corrections, and then it's possible to do here simple spectra. And it looks like it's in this spectrum is in displacement, not in velocity, if you look. And this manual, let's say, is trying to cover, you see here, this part to the digitization, to give you a digitized waveform that you might use at as you like. For this, we design a first tentative with these contents, an introduction, saying what is the objectives, etc. The morphology, because they change along the years. The timing, now also the young people think that timing is, well, it's just in the millisecond or even less. No, it was not like this. Till, for example, in 45, in the moment, or up to the 50s, up to the most modern clocks. To be in the second, it was really good. Well, and here the main topic: how to digitize. Techniques, tips. There is a lot of tips. I mean, it's not a big science on all this, but if you know, this is saving you a lot of time. The transfer function of those all instruments, and finally some examples for you to work. Much more. This is much more detailed. It's the same index. You can download it. I mean, I'm not going to stop. You have it in the Congress website. And now we have already a very preliminary version. I have here a print for your inspection. It's still very preliminary. It's like the previous manual that takes a couple of years. This we are just starting. Let's say that it's going to take to have a quite definitive version that looks nice and everything is on place. But now it's covering this introduction, an overview on seismology, and morphology, how to scan and digitize some tips, some ideas. All the corrections that should be applied to that digitized seismogram and timing, the transfer function. Also, there is a small chapter in bulletins. You still can get new data from bulletins, from all bulletins. It's interesting. And finally, the application is more or less the same. And just a couple of examples. I'm not sure anything about bulletins, but it's interesting. No, I'm sorry, I'm showing that. Just to show the old students, I'm mixing. The young students, they take an old bulletin and they're looking for the poles and zeros, like in Minisit. And where is this? Where are the poles? No, they are not there. You find something really different. This is from Wien, Wien in 1910 or something like this. But is this, the transfer function of a mechanical seismograph is this, it's very easy. It has just 2 zeros in displacement, 2 zeros and 2 poles. And the magnification is in the bulletin, the free period also. But the damping we are using now is not exactly in the bulletins, it's this epsilon. But it is very easy to pass from this value of epsilon to the value of the damping. But is this, for example, a student that has 7 seen this doesn't know. At that time, it was very easy to calculate this value of epsilon. Now we don't care. Even I prepare a table with the values. I mean, you don't need to make even the calculation. For the electromagnetic instruments, it's the same. This is really the transfer function is not exact. This is a simplified version. We need the coupling, but a lot of instruments that have coupling almost 0. It has 3 zeros and 4 poles, and it's the same. In the bulletins, you find something different. But in the case of Galitzin, this K is called the transmission factor, but it's written in the bulletins. The A is just the length, the distance between the galvanometer and the mirror is so easy as this, when you know, and the L is the length of the simple equivalent pendulum, but also is a value given in the bulletins, and other things that I'm not going to stop. In the case of the Galitzin, this amplification is just this value. Okay, but you find other tips. For example, this is from Strasbourg, and there's a page of calibration, and we see this logarithm of C1 value. What is this? Well, it's, when you know, it's very easy. These values here in the third line is a combination of the values I say before. And if we know which is the maximum magnification, it's very easy to calculate it. For example, I remember the bulletin of La Paz in Bolivia give this C value instead of the K value. Well, and the logarithm, you should remember also the old people aside that still use some logarithm tables and not a calculator. The way to write the logarithm, you should know that this 2 is not a negative logarithm. To get the negative logarithm that we apply in the calculator, you have to take the value of 2 and subtract the rest of the value. And when you apply this, you get this. This is no science, no, but you can be stopped. If you don't know, you can be stopped for 1 week before. I'm not able to obtain that value. Well, just you remember, this is not applying so much to the time of nuclear explosions, because after the publication of the Ch3 and Bullen tables, the phase nomenclature was quite stable up to now. There is small changes. But before, after First World War, the Mohorovich's nomenclature become common. And this is an example of the bulletin of the Toledo Observatory, where in an earthquake at 300 kilometers, the analyzer tries to fit its wheel to a reflection from the crust. It's just crazy. It's giving like 10, 12 phases in 20 seconds, if you look. Well, but you should know, you might find things like this. It's easy when you know to pass to the present nomenclature, but you should know. And just to finish the next steps, is I think in the next weeks this example will be already available at the website of the European Seismic Commission Working Group on legacy seismograms. But also a second now coming back to my office, I will start to rewrite everything and to make it larger. On another side, this is an introductory chapter just for you to know the first steps to do and where to find the references. Most of them are already scanned. The problem is to know where they are. I mean, you cannot write now a book of 300 pages, I would like, but for this objective should be much smaller. We should add exercise as other chapters of the new manual, while it's a complement of the previous presentation altogether, and in the future, I think it will be a good complement of the project falls also, because it should be easy in that time to get the scanned seismograms and to play with them. And 1 year ago I say volunteers and still looking, but any comment, any volunteer to write some topic is really welcome. You can contact Rafael or myself, or directly you write to the SSE working group. And that's all I want to tell you now. Thank you very much.
Thank you so much for your very interesting topic. So we have time for some small questions, please. I'm sorry, microphone.
Yeah.
So you said you would like to have some examples for this chapter. What kind of examples you have been thinking of?
We can have examples of how to correct the curvature given the length of the stylus, but how to correct time. For example, I had to do this for I remember an earthquake some years ago. I have to do the correction. How you pass from the time on the seismogram to the time on the bulletin, to read amplitudes, the magnitudes, all these kind of things, but directly on the analog instrument. These are also to find the poles and zeros of the transfer function. We have the bulletin. Let's see if these are, for example, 4 examples already. I mean, for exercise to do.
Thank you so much.